Hello, this is Garth Wiley from 6DOF Testing and Analysis. Today we're going to do a brief overview of several product structural validation approaches. And these approaches are based on things that we've been involved in over the years and have gained some experience. The four approaches we're going to cover are highlighted here in yellow, and we're going to briefly overview those. However, there are more detailed videos that we've developed covering more information on each one of these approaches. These approaches tend to be guided by simulation activities, as we'll describe a little later. Our customers generally handle the design aspects of the product. We really don't get involved too much in the design. But we do sometimes help on the front end of defining duty cycles, loads, and operating conditions. For example, turning a part into a load cell, taking data out in the field where there might be a very special, important loading condition. Sometimes this data is acquired over a long period of time, looking for maybe rare, large, significant events. Our validation approaches often involve partnering with our customers in the sense that sometimes depending on training needs or budget needs, we may actually have our customers do some of the instrumentation, for example, laying strain gauges, where we may actually control the test over the internet, but they might provide our hands on site. And exactly how these approaches, these validation approaches are implemented depends a lot on the nature of the product, and we're often adapting to specific situations, sometimes combining some of these activities and so forth. These various validation approaches are often guided by simulation activities. And sometimes the simulation model used might be something that was actually used in the product design process. Or sometimes a derivative model is used to help us identify sensor locations. For example, we may use some inertial loadings on a structural model to identify strain gauge locations. And that is often very critical because if we don't get the strain gauges in the right place, that data is not going to be helpful. And then, of course, forces, accelerations, and displacements are often guided, those types of measurements are often guided by the simulation model. One approach is field test validation. And this is where we essentially take the structure, vehicle, or whatever, and operate in its normal environment while we're making important measurements for the validation. Sometimes this is called road load data acquisition, RLDA. And what we're trying to do is measure the typical duty cycle and be sure we include large rare events, which might be very important. We often include staged events, which often are used to validate our simulation models. This helps us to gain confidence in the models if the comparisons of certain inertial loads and certain static or twist loads seem to match between test and analysis. In addition, sometimes we can scale some of our measurements using the model. For example, there was a place we thought might be a high stress area, but we couldn't get a strain gauge in that location. The model can help us to extrapolate to that particular high stress area. Another validation approach involves durability rig testing, where the structure may be a component or subsystem, or perhaps the entire full system structure is evaluated on a rig, usually powered by hydraulic actuators. Now, the loadings for these rig tests are often determined from a road load data acquisition type of test, where out on the road we may actually measure loads or other type of responses that will help us develop the drive files for the full system or component test. The objective here is usually to do an accelerated fatigue damage evaluation. Most of the time, these loads are dynamic, but sometimes we've actually done rig tests where the loads are static, and we're actually trying to correlate those static loads to a simulation model. Proving ground validation testing involves driving an instrumented vehicle over a proving ground durability course or particular staged events. Sometimes the proving ground validation testing actually becomes a hybrid involving either durability rig or field validation tests, in the sense that the field validation tests might be used to scale the durability course that the vehicle has been driven over, in trying to equate that durability course to so many miles of a particular duty cycle that was measured with a field test. Or it could be used in supporting rig validation testing, where the validation rig, the hydraulic rig that might apply loads to a structure in a lab, is used to do an accelerated damage type of testing. And another thing that's often done on a proving ground is a to B type comparison, where perhaps a known design with a known life and so forth is compared to a new design over the same type of course. So that becomes a comparative type of analysis. Most of our experience in rotating machinery system validation has involved reciprocating equipment, and particularly equipment that might be diesel generators or reciprocating pumps and so forth. And in that situation, we're really usually looking at the system, where a perfectly good engine and a perfectly good pump, for example, are brought together in a system. They've all been well qualified, but now the question is, how well does that system work together in terms of vibration, stresses, and strains? And again, we use a finite element model to help us identify strain gauge locations, for example. And we use operating tests of the system to measure vibration, stresses, and compare it to targets. In addition, often modal tests are used to identify resonant frequencies and mode shapes, and to compare these types of test results to the finite element analysis as well as the operating test information. So this completes our overview of 4 validation approaches, which are by no means complete in the validation world, but these summarize areas where we've had a fair amount of experience. And once again, we invite you to look at the more detailed videos that are available for each of these 4 types of validation approaches. So thank you for listening. If you need more information, please contact 6DOF Testing and Analysis. This is our website and our email, and of course our phone number. And again, thank you for